Guys, we're going to solve this spooky Gaussian integral in just 4 steps. So, first we need to do is square the integral. So I squared equals this, e to the minus x squared times by the integral of times dx, sorry, of e to the minus y squared times dy. So this equals the double integral between infinity and minus infinity of e to the powers add, so x squared plus y squared, and then with regards to dx dy. This is step 1. Step 2 is convert to polar coordinates. Exclamation mark. So when we do this, we set x squared plus y squared equal to r squared, and we set dx dy equal to theta, equal to r dr d theta. So now we've got to look where are x's and y's and where are dy's, dx's, all this jazz. So we're going to do the double integral of e to the minus, and now x squared plus y squared is r squared, dx dy is r dr d theta. Now what are our bounds now? So if x squared plus y squared equals r squared, our bounds for the inner is with regards to r. So r can span between 0 as a minimum to infinity as a maximum, and theta can go from 0 as a minimum to 2 pi as a full rotation. So we're going to be left with this. So the outer integral is with regards to theta, and the inner integral is with regards to r, so between infinity and 0 of e to the minus r squared r dr d theta. So I need to rub out this. Step 3, integrate the inner integral. So we've got this, right? Infinity minus infinity of e to the minus r squared times r dr. This is this part of the integral, right? The inner integral. So what is this? Well, first we need to let r squared equal to u. I don't know why I wrote that way around. I'll write it that way around. But u equal r squared, so du equals 2r times dr. So now we've got the r squared, but we don't have the 2. So we need to half the integral and times the whole thing by 2, r. So we've got that. And then we've got to write e to the minus r squared, so u all. So now we've got the 2r, dr is du, and we've got the minus u subbed in, so this is just the integral of e to the minus u du, which we can all solve. This is looking good, baby. So now what is this? Half the integral between infinity and 0 of e to the minus u du equals 1/2. This integral is minus e to the minus u between infinity and 0, which equals 1/2 of minus e to the minus r squared between infinity and 0. So e to the power of infinity minus infinity just converges to 0. So this is 1/2 of 0 minus e to the power of 0 is 1. But it's minus times by minus 1, which gives us 1/2. So this is the inner integral, is 1/2. So now the outer integral was, what was it? It was 2 pi and 0 of 1/2 times d theta, which equals theta over 2 between 2 pi and 0, which is just 2 pi over 2, which is just pi. Remember, this is the integral squared. So this is step 4, solving the outer integral. So I squared equals pi. So the integral equals root pi. And that is the Gaussian integral solved.